Okay, so here we have a problem from chapter 15.6. So this is doing triple integrals. It's the first section on triple integrals. We're just right now working in Cartesian coordinates or rectangular coordinates. What you'll notice when you first look at these problems is it looks more complicated because I have a lot more variables that are involved in my problem. Really, we're only integrating with respect to one variable at a time. So it's just a Calc 1 problem that you're doing 1, 2, 3 times in a row. So as you notice, all the variables, what's going to be really helpful is to go a little slow and make sure you're paying very close attention to the details. These turn into a lot of babysitting problems because of all the variables that are happening. So one of the things we talked about is to keep everything kind of in order. dz is my first variable, so I'm going to label the integral with the z next to it, because that's going to tell me, hey, that's my first variable. Then here I have x, and then I have y. Just as a reminder as I work to help me focus on what my integral is or what variable I'm paying attention to. So here, I'm just going to start on the inside and do this integral first. I'm going to draw that up a little further like this. So I have the integral of 6xy dz. Notice, so this is telling me z is the variable I'm integrating with respect to. So here, my xy, these are just all constants. I have a constant of 6xy. That means that this antiderivative will be 6xy and then z. And I'm going to evaluate that from z equals 0 to z equals x plus y. So notice as I write this out that I do my antiderivative, and then I'm very specific as to what variable I'm going to replace when I go to evaluate. It's going to be really easy. So I have 3 variables here. If you just write your evaluation bar and I write from 0 to something, by habit, you're going to want to plug it in for x. So that's like your default thinking. So go ahead and make sure that, just to help you out for now, I would suggest labeling this so that you're very, very particular about the details. When I plug in 0, that's going to do nothing for me. It's just going to cancel out. So all I'm going to evaluate here is x plus y. So I have 6xy times x plus y. This is going to turn into a distribute. So I get 6x squared y plus 6xy squared. That's what's going to go back here into my next integral that I'm going to solve. So I'm going to now rewrite this. Now I'm just doing a double integral. So from 0 to 1, that's my y value. And then from y to 2y, that's my x value. And then now I have 6x squared y plus 6xy squared. So now again, what I'm going to do is I'm going to take just the integral on the inside. I'm going to look and focus at just this part here. So when I do that, x is the variable that I'm paying attention to. So in the first component here, my 6 and my y are just constants. So I'm just finding the antiderivative of x squared. The antiderivative is 1/3 x cubed. So the 1/3 and the 6 are going to give me a 2 x cubed y plus here, now I just have an x by itself. So that antiderivative is going to be 1/2 x squared. So it'll give me a 3x squared y squared. I'm going to evaluate this from x equals y to x equals 2y. So again, as I'm going to label and make sure I'm very particular about what values I'm plugging in for which variables. Let's go ahead. I'm going to work this out now. So starting up here, I actually have to do my fundamental theorem and evaluate this out because I don't just have a 0 that I'm plugging in. Okay. So that's going to be 2 times 2y cubed times y plus 3 times 2y squared, y squared. And then I'm going to subtract, so I can write this again smaller, 2y cubed y plus 3y squared, y squared. Barely fits in, perfect. So here, let's work this out. 2 cubed is going to be 8 times 2 is 16. That's y cubed times y. 16 y to the 4th. 2 squared is 4, so that's 4y squared. It'll give me 12y squared times y squared is 12y to the 4th. Over here, so this is 2y to the 4th plus 3y to the 4th. So that's minus 5y to the 4th. 28 minus 5 is 23. So now this, I'm going to rewrite it over here in my blank space. This is what I'm going to plug into my next integral. Now I'm going to calculate. So this was my dz, this was my dx. Now I'm going to have to do dy. So I'm going from 0 to 1, 23, y to the 4th, dy. Now at this point, I have only one variable. I have just y's. So I can just do a regular single integral. Antiderivative is something to the 4th is going to be y to the 5th over 5. So I'm going to get 23 fifths y to the 5th. I'm going to evaluate that from 0 to 1. So again here, 0 doesn't do anything for me. It'll give me 0. When I plug a 1 in, I'm just going to get 23 fifths. So that's the idea or the process. Let me fix it. As you're looking at this, that's not where I plugged it in. This got plugged in over here to my integral. Sorry. That's my process for a triple integral. Make sure that you're paying attention to the different variables. So you really need to pay attention to the details, okay? So if you got questions, if you're not sure about something, send me an email. Let me know so I can help you out.